Atmospheric pressure is the pressure I feel from the weight of the air column above me pushing down on top of me. I can measure atmospheric pressure by measuring the force that column of air exerts on top of me. The unit used to measure pressure is called the bar, and at sea level, on an average day, atmospheric pressure is roughly 1 bar. A barometer is the instrument used to measure pressure by measuring the force exhibited on some sensor by the air around it. Here, as the bottle cools, the pressure inside the bottle drops, and the atmosphere, which is a higher pressure, exerts a pressure on the bottle, and the bottle collapses. The pressure in my experimental chamber, or spacebox, is 100 billion times lower than atmospheric pressure. There are just not enough particles inside the chamber to detect the pressure inside as a force, so instead we have to find some other way of measuring the pressure inside our vacuum chambers. We do this using an ion gauge. Here, we can see the ion gauge turning on. An ion gauge allows us to detect indirectly the number of particles or molecules that are present inside the chamber. So, the ion gauge has a hot filament, which is made from tungsten. That's the bit that glows red, and that emits electrons. So the electrons come off the filament in all different directions. When one of the molecules that's in our chamber collides with one of those electrons, that electron has enough energy to strip an electron off the molecule to make that molecule into a positive cation. The cation is then attracted towards the collector. That's a single wire that sits at the very center of the gauge. It's negatively charged relative to the positive cation, and so every time an electron collides with a molecule to make a cation, the collector wire measures a current. In this way, by measuring the current here, we have a surrogate for the pressure in the chamber. The more molecules there are, the higher the current that we measure. It is very important to know the pressure inside our vacuum chambers so that we can properly conduct our experiments. We need to know that the pressure is low enough to simulate the environment that we want to recreate in space. We need to know that our spacebox is sufficiently empty before we begin to conduct the experiments. The ion gauge is an essential piece of equipment for each and every experiment.